Today we're talking about identifying linear functions. A linear function is a function whose graph forms a straight line. And we want to identify whether each graph represents a function and is it linear. So first of all, let's start with y equals x minus 4. Now we've made tables before to graph. So let's go ahead and do that. Let's choose some numbers for x. Let's choose 1, 2, 3, 4, and 5, say. Well, if we plug in the numbers, 1 minus 4 gives us negative 3. 2 minus 4 gives us negative 2. 3 minus 4 is negative 1. 4 minus 4 is 0. And then 5 minus 4, of course, gives us 1. All right, so we have the points 1, negative 3, 2, negative 2, 3, negative 1, 4, 0, and 5, 1. Now, right off, we know that this is a function because the x's do not repeat themselves. Now, let's graph this and see if it's linear. So we have the point 1, negative 3, 2, negative 2, 3, negative 1, 4, 0, 5, 1, and sure enough, if we connect those, we do get a line. All right, and so that is linear. It also passes the vertical line test, so that's another way to tell if it's linear. Now, right off looking at this one, this is a function. I'm sorry, no, I'm looking at the wrong one. This one I'm talking about. This one is a function because it passes the vertical line test, but it is not a linear function. It does not make a straight line. So it's this little curve I'm looking at right here, up next to number 2, which kind of runs into our table. Now, here we'll go to number 3. Number 3 is just a straight line, a perfectly vertical line going up and down. It is linear, but that is definitely not a function because it does not pass the vertical line test. Now, we want to tell whether each set of ordered pairs satisfies a linear function. Now, here's what we can do. Let's look at the differences between the x values and the y values. If we get consistency where the differences are the same, yes, it will be a function. So let's look. Between 0 and 4, it increases by 4. Between 4 and 8, it increases by 4. Between 8 and 12, it increases by 4, and between 12 and 16, it increases by 4. Let's do the next one. Between negative 3 and 0, it increases by 3. Between 0 and 3, it increases by 3. Between 3 and 6, it increases by 3. And between 6 and 9, it increases by 3. So the differences are the same between the x's, and the differences are the same between the y's. You could think of it, here's your x, here's the starting point for your x. You move over 4, let's say this is 4 spaces, 1, 2, 3, 4, and then you go up 3, 1, 2, 3. Of course, I'm just sketching this here. And you just continue to do that. Go over 4, the same amount, and up 3. The step stays the same. I'm not drawing this very well, but you get the idea, so that we get that straight line. It is a linear function, first of all, because the x's never repeat themselves. And also, if you graphed it, it would pass the vertical line test. So we're going to say this is a linear function. What makes it linear, the difference between the x's are the same, and the difference between the y's are the same. That part makes it linear. Let's do the next one. These points. Difference between negative 4 and negative 2 is positive 2. The difference between negative 2 and 0 is positive 2. Between 0 and 2, the difference is positive 2. Between 2 and 4, the difference is positive 2. Let's do the next one. 13 to 1, the difference is negative 12. Between 1 and negative 3, the difference is negative 4. Stop right there. The differences between the y's are not the same. So this is not linear. However, is it a function? Do the x values repeat themselves? No, they don't. So that alone makes it a function. It's not linear, but it is a function. So let's move on. We want to talk about standard form of a linear equation. Standard form is ax plus by equals c, where a, b, and c are both where a, b, and c are all real numbers and a and b are not both 0. So for instance, 3x plus 2y equals 10. Here your a is 3, b is 2, and c is 10. Tell whether each function is linear. If so, graph the function. Well, we know that this is going to be linear if we can get this into the form ax plus by equals c. Okay, so is that the case? Well, so we got to get x and y on the same side. So we'll have to subtract 2y from each side. So we end up with x minus 2y equals c. Well, really, the number in, equals 4. C is our 4. Let's put 1 in front of the x. That's really what the number is. Now, this is the same thing as having 1x plus negative 2y equals 4. So does that take the form ax plus by equals c? It sure does. A is 1, b is negative 2, and c is 4. So we definitely know this is linear. So now, since it's linear, let's graph it. Now, to graph it, we do want to get y alone. We want to solve that original equation for y. So let's go back to do that, because we want to fill in our table. So we have x equals 2y plus 4. So let's get y alone. We'll subtract 4 from each side. This is really like having a 1 in front of the x, so we get 1x minus 4 equals 2y. To get y alone, we divide everything by 2, everything we see. And so I'm going to put y on the left. So we get y equals 1/2 x. Negative 4 divided by 2 gives you negative 2. So we have y equals 1/2 x minus 2. So we're going to make our table for x's and y's. Now, I would choose numbers that would cancel out with a half, so even numbers and also 0. So we have 0, let's do 1 and 2, and then let's do negative 1 and negative 2. Let's try that. So 1/2 times 0 minus 2, that's just going to give you negative 2. Oh, wait a minute, and I did not choose even numbers, so let's go back and do that. I just said we wanted to do that. Let's go ahead. So we're going to choose, say, negative 2, negative 4, and positive 2, positive 4. So let's go ahead and do that. So we have, for our even numbers, 1/2 of negative 2 is negative 1. Negative 1 minus 2 is negative 3. 1/2 of negative 4 is negative 2 minus 2 is negative 4. Then 1/2 of 2 is 1 minus 2 is negative 2. I'm sorry, is negative 1. Let's change that. 1/2 of 2 is 1. 1 minus 2 is negative 1. And then we have 4. 1/2 of 4 is 2. 2 minus 2 is 0. So now let's go ahead and graph those points. So we have 0, negative 2, negative 2, 3. I'm sorry, negative 3. Negative 4, negative 4. 2, negative 1. I moved it to the wrong spot. 2, negative 1. And 4, 0, which is right here. Okay. And now let's draw our line. and we do get a straight line. We knew it was going to be linear. It is definitely a function because it passes the vertical line test. Okay, so next one, we have B, where we want to know if xy equals 4. Is that a linear function? Can that be written in the form ax plus by equals c? And there's no way. There is no plus sign between x and y. They're being multiplied. There's no way we can put a plus sign there. So this is not linear. I'll draw a line here so as to separate it from the other problem. Not linear because it cannot be written in standard form. Next, the relationship between human years and dog years is given by the function y equals 7x, where x is the number of human years. Graph this function and give the domain and range. So let's start. X and y equals 7x. So let's pick some numbers to put in for x. Let's pick 0, 1, 2, 3, 4. Okay? So y equals 7x. 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 4 times 28. And 4 times 7 is 28. Okay, so we're going to graph the points that we can. We obviously can't fit all of them on the graph. Okay, we just keep going on and on and on. So you can see this graph's just really going to keep going. It goes forever, or it seems to keep going. Now, except, I'm going to say it seems to keep going. It definitely keeps going in this one direction. But let's think about this. It says the relationship between human years and dog years is given by the function y equals 7x. Is it going to go beyond 0? Are we going to go into x values or y values that are negative? Well, you can't have a dog that is a negative number of years old, and you can't have a human that's a negative number of years old. So it's basically got to start right here at 0. Okay? It's going to keep going. Okay, there's probably a limit at some point as to how old a dog or a human can be. But if we want to write the domain and the range, we are going to say that the domain, the x values, they have to start at 0. Okay? When the dog is just barely born or the human is just barely born. And so we're going to say that x can be greater than or equal to 0. The range, the age of the dog can only start at 0. And so y is going to have to be greater than or equal to 0, because you can't have a dog that's a negative number of years old. So that is it for today. Thank you very much for joining me.